In the last set of lectures, we talked about project management and how you'd arrange project management. In this set of lectures, we're going to talk a little more about project finance. But first, let's look at a few engineering quotes. And these are ones that I particularly like because it reflects the important difference between a scientist and an engineer. And the key thing to appreciate as engineers is you're inventors, you are creators. You're not studying the world as is, you are changing the world forever. And that comes with a large responsibility. It's important that you do it correctly and you do it professionally and you do it with care and precision. We're now going to talk about engineering project financials. And I would like to thank Paul Younger, who used to be the Rankin Chair of Engineering for Energy. So the objective of this lesson is to clarify what engineers themselves need to take a closer look in financial projections for the projects, and then to explain some of the techniques used in constructing financial projections for engineering projects. And we'll talk about levelized cost, discounted cash flow, net present value, and internal rate of return. But the unofficial objective here is to make you an accountant's worst nightmare. An engineer who understands the basic and principles of finance is a very, very dangerous creature indeed. And accountants run with fear. I thought I'd take a short time, somewhat tongue-in-cheek, to talk about engineers versus accountants. And on the left here, I have illustrated an accountant's calculator. The advanced functions in an accountant's calculator would be perhaps divide and multiply, with plus and minus being the normal. Whereas if we look at an engineering calculator, standard functions are sine, cos, hyperbolics, squares, logs. We are highly numerate. In fact, engineers are some of the most numerate people in society. You have got more mathematical training than any accountants, and the only one that will come close is the pure mathematicians and some of the physicists. So I've just said what you're doing in engineering and, why do you need to care about project finances? Let's look at why an engineer is different from a scientist. Engineers have two roles to play. They have to balance and address societal needs with scientific knowledge, and they apply their engineering to address those. On the other side, they have to address the analytical side with creativity, and they have to mold these forces to deliver an effective solution at the end. The reason that engineers need to understand finance is that nothing kills a project faster than bad financial predictions. And in this instance, poor does not only mean unfavourable, it can actually mean very poor representation. Someone who underestimates a sales potential is just as guilty and should be equally punished as someone who overestimates a sales potential. Engineers must concern themselves with a financial case for their projects because it is their projects and they're the ones who actually care. And also, engineers should be able to do this sort of analysis at least on the basic level, because it allows you to engage with your professional financial team, be it accountants or financial advisors, and talk in their language to them. And that's very useful. And it's something that I've used throughout my career, although I spent most of my time being a very hands-on practicing engineer in development. I'm also very skilled at putting together a business case. Why do you need to do financial projections? Well, let's look at a couple of small things with projects. Sometimes it's enough just to know how much the project will cost. Building a building, building a new car. But the capital cost for most projects is actually only part of the cost, the capital expenditure or CapEx. In an engineering design, be it a machine, be it a car factory, be it a piece of electronics, be it a piece of software. Software actually has a huge operating expenditure, an OPEX. It may cost you $100 to buy the piece of software, but how much time do you spend supporting that software throughout the life? Adjusting it, downloading drivers, rebooting, these all add up. And the operational expenditure for any future revenues that are costs associated with a project are equally important to a project. But you can't just quantify the CapEx and OpEx. You need to be able to compare and contrast between different projects and different ways of doing the same project. There might be a different method of construction of, say, a bridge. You can construct it from steel, you can construct it from stone, you can construct it from wood, you can construct it from many different materials, and each will have a different CapEx and a different OpEx. So therefore we need methods of being able to present the model here for CapEx and OpEx and allow us to compare a like with like comparison. And this is a key part of financial projections for projects.